Hi everyone. The topic that I have chosen is anomaly detection. So, firstly, what is anomaly detection? One of the most popular applications of machine learning is anomaly detection. Outliers can be found and identified to assess stop fraud, adversary assaults, and network breaches that might jeopardize the future of the businesses. What is anomaly? We must first define an abnormality before we can discuss anomaly detection. An anomaly, also known as a variation or an exception, is often something that deviates from the usual. In the context of software engineering, an anomaly is an unusual occurrence or the event that deviates from the norm and raises suspicion. Examples include fast spike or decrease in activity, or textual mistake, or a sudden rapid drop in temperature. Typical causes of outliers include flaws in data preparation, noise, fraud, and assaults. A software program must function smoothly and predictably. Thus, any anomaly poses a possible risk to the robustness and security of the program. Normally, you want to detect them all. Anomaly or outlier identification is a process of detecting anomalies. For example, if large sum of money are spent one after the other within one day and it is not your typical behavior, a bank can block your card. This will see an unusual pattern in your daily transactions. This anomaly can typically be connected to fraud since identity thieves try to steal as much as money they can. Type of anomalies, we have three types of anomalies. The first one is global outliers. When a data point assumes a value that is far outside of the other data point value ranges in the data set, it can be considered as a global anomaly. In other words, if you receive an average American salary to your bank accounts each month, but one day you get $1 billion, that would look like a global anomaly. Next comes the contextual outliers. Contextual outliers, when an outlier is called contextual, it means that its value doesn't correspond with what we expect to observe for a similar data point in the same context, are usually temporary. In the same situation observed at different times cannot be an outlier. For example, for stores, it's quite normal to experience an increase in customers during the holiday season. However, if a sudden boost happens outside of holiday or sales, it can be considered as contextual outlier. And the third one is collective outliers. Collective outliers are represented by a subset of data points that deviate from the normal behavior. In general, tech companies tend to grow bigger and bigger. Some companies may decay, but it's not a general trend. However, it may ensure to show a decrease in revenue in some period of time. So, why do you need machine learning for anomaly detection? This is a process that is usually conducted with the help of statistics and machine learning tools. The reason is the majority of companies today that require outlier detection work with huge amounts of data transactions, text, image, video content, and so on. You would have to spend days going through all the transactions that happen inside a bank every hour. The more and more they are generated every second. Moreover, another difficulty is that the data is often unstructured, which means the information wasn't arranged in a specific way for data analysis. To be able to collect clean, structure, analyze, and store data, you need to use tools that aren't scared of big volumes of data. Machine learning techniques, in fact, shows the best results when large datasets are involved. Machine learning used for real world applications helps to streamline the process of anomaly detection and save the resources. What are anomaly detection methods? They are supervised, unsupervised, and semi-supervised. Uh, s- Firstly, supervised and supervised anomaly detection. An ML engineer needs a training dataset. Items in the dataset are labeled into two categories, normal and abnormal. The model will use these examples to extract patterns and be able to detect abnormal patterns in the previously unseen data. In supervised learning, the quality of the training dataset is very important. There is a lot of manual work involved since somebody needs to collect and label every example. Unsupervised, this type of anomaly detection is the most common type and most well-known representative of unsupervised algorithms are neural networks. Artificial neural networks allow to decrease the amount of manual work needed to pre-process. Um, an example is no manual labeling is needed. Neural network can be applied to unstructured data. Neural networks can detect anomalies in unable data and use what they have learned when working with new data. The advantage of this method is that it allows you to decrease the manual work in anomaly detection. Moreover, quite often it's impossible to predict all the anomalies that can occur in a dataset. Moreover, the architecture of neural networks is a black box. We often don't know what kinds of events neural networks will label as anomalies. Moreover, it can easily learn wrong rules that are not easy to fix. In semi-supervised learning and anomaly detection methods combine the benefits of previous two methods, engineers can apply the unsupervised learning methods to automate feature learning and work with unstructured data. However, by combining it with human supervision, they have an opportunity to monitor and control what kinds of pattern the model learns. Here comes the machine learning algorithm for anomaly detection. The local outlier factor. The local outlier factor is probably the most common technique for anomaly detection. This algorithm is based on the concept of local density. It compares the local density of an object with that of its neighboring data points. If a data point has a lower density than its neighbors, then it is considered an outlier. The k-NN neighbors. The k-NN is a supervised ML algorithm often used for classification. When applied to anomaly detection problems, k-NN is used tool because it allows to easily visualize the data points on the scatter plot and make anomaly detection much more initiative. Instead of learning normal and abnormal values to solve the classification problem, k-NN doesn't perform any actual learning. Support vector machines. This SVM is the supervised machine learning algorithm often used for classification. SVMs use hyperplanes in multi-dimensional space to divide data points into classes. The hyperparameter is the threshold for outliers, which you have to choose manually. This is the supervectors graph, which with class A and class B, and the margin. Next, the DBSCAN. This is an unsupervised ML algorithm based on the principle of density. DBSCAN is able to uncover clusters in large spatial dataset by looking at the local density of the data points and generally showing good results when used for anomaly detection. Autoencoders. This algorithm is based on the use of artificial neural networks that encode the data by compressing it into lower dimensions. The ANNs could decode the data to reconstruct the original input. When we reduce the dimensionality, we don't lose the necessary information because the rules have already been identified in the compressed data. Bayesian networks enable ML engineers to discover anomalies even in high dimensional data. This method is used when anomalies that we are looking for more subtle, harder to discover. Basically, anomaly detection is used for intrusion detection and fraud detection and health monitoring. So in intrusion detection, cybersecurity is a key for many companies that work with confidential information, intellectual property, and private data of the employees and clients. These intrusion detection systems monitor the network to detect and report potentially malicious traffic. Some examples of these are software Cisco systems and like AF. Fraud detection, while machine learning helps to prevent activities aimed at obtaining money or property unlawfully, fraud detection software is used by banks, credit organizations, and insurance companies. The health monitoring. In health monitoring, they are incredibly helpful in healthcare. It helps doctors with diagnosis, detecting unusual patterns in MRI and test results. Usually, neural networks that have been trained on thousands of examples are applied here. And defect detection. Anomaly detection systems that use computer vision can detect if the detail has a defect even among thousands of other similar details in the belt line. Moreover, anomaly detection systems can be connected to the mechanisms of monitor internal systems such as engine temperature, fuel levels, and other parameters. Summarizing the topic here, the conclusion is anomaly detection is identifying data points in data that don't fit the normal patterns. It can be useful to solve many problems, including fraud detection, medical diagnosis, etc. Machine learning methods allow to automate anomaly detection and make it more effective, especially when large datasets are involved. Some of the common ML methods used in anomaly detection include LOF, autoencoders, and Bayesian networks. Thank you.